One of the biggest problems with the way that organs are allocated today is that geography can play a huge role in whether patients in need live or die. And this really hit home for my team and I when we read an article about two patients living in New York, Mark and John, who both were in need of a liver. And John, after 10 years on the wait list, was in complete liver failure, but he still wasn't considered sick enough by New York standards to receive a liver. And that's because there are thousands of patients that are vying for this same scarce supply of livers. And he actually ended up dying of liver failure and he never got the organ that he needed. Frank, on the other hand, moved to Florida, which has some of the highest donation rates in the country. And a week later, he received a new liver. Unfortunately, Mark and John's story is not at all uncommon. Every day, 22 people die of organ failure in the United States, and there are over 120,000 people on the wait list. Organ allocation strategies have a large impact on waitlist mortality, and because of the geographical inequities that are caused by the way that we currently allocate organs, there's a large movement to change, redistrict, or even altogether eliminate these geographical boundaries. If this were to happen, there would be a large increase in the frequency of air transportation for organs, and the system is not currently equipped to handle that. So my group wanted to approach this problem by finding ways to optimize the transportation for this future system where air becomes the dominant mode of transportation for organs. We're LifeLine, and we've created a model to optimize air transportation for organs and save lives.
In our project, we partnered with LifeLine, which is an aircraft design and manufacturing company with an assembly line in northeast of Philadelphia. LifeLine has a new product called the AW609 tilt rotor, which is a hybrid between a helicopter and a fixed-wing aircraft, capable of flying at twice the speed as a normal helicopter, but also has vertical takeoff and landing capabilities and can also land on regular helipads. We got the opportunity to visit the LifeLine facilities in northeast of Philadelphia, and we got to see the aircraft, look at the simulator, and have a better understanding of their product in order to deliver better solutions. At the end of our project, we had a meeting with our stakeholders in order to deliver the results and have recommendations for further research.
Given that we were simulating a real-world system, we had to consider realistic constraints and figure out a way on how to translate these into a specific mathematical model. So we therefore created a single vehicle static model which took into account certain variables such as the distance between transplant centers, the earliest pickup and latest delivery time for an organ, as well as the speed of the vehicle. Our model took these inputs into account, this set of inputs, and schedules an optimized route for that vehicle by maximizing the profit for each specific transit time. We got some fulfilling results as we were able to complete many more requests when using the speed of the AW609 tilt rotor as compared to using the speed of a regular helicopter.
So two of our biggest challenges in our project were one, acquiring data, and two, understanding the complexities and the logistics of the organ transportation system. On one hand, acquiring data was very difficult because a lot of the data is protected by the government and it's very hard to acquire. We did a lot of research, we requested a lot of data, a lot of sources where we never heard back from, and then some that were helpful. But then we felt the need to have a better understanding of the whole system, and in order to do that we met with Gift of Life, which ended up also being one of our partners. Gift of Life is the organ procurement organization here in Philadelphia, and they were able to give us a more system-wide approach of solving our problem, but they also provided us with data that we use to test our model.
After meeting with the Gift of Life and understanding the vast inequity between supply and demand, we realized that all organ transport requests are always fulfilled. So we decided to design a new, more complex model that incorporated this new constraint. Our new model is a more realistic reflection of the way the system would actually work and optimizes the number of tilt rotors and helicopters and fixed-wing jets that would work simultaneously to complete a set of organ requests.
So far, we've gotten very positive feedback from our main stakeholder, Augusta Westland, as they have expressed interest in continuing this analysis and developing the model with us in the future.
Given the current trend toward redistricting the regions used for organ allocation, air transportation is likely to become the dominant mode of transportation for organs. And this presents a large opportunity for LifeLine to optimize the logistics of this system and to give AW a competitive advantage in this market. We would love for you to join us on our journey and help us save lives. Thank you.